Hey everyone, I'm back and I know grown, just a little bit more introduction about Wireshark. Now, I'm talking about using Wireshark for cyber security. Now, we have used Wireshark so far for just a general idea, so I know you installed it and everything is good. But we're going to talk more specifically today, and really, when it comes to Wireshark, you've probably used it in other classes. I know we've used it in here already in the first 3, 4 weeks. But when it comes to Wireshark for cybersecurity, you're looking at the ability to capture, to filter, and investigate network traffic at the packet level, which is key for network forensics. Now, when it comes to this particular slide, if we can take a look, now this is specifically only for those of you that are dumb enough, like myself, to have purchased a MacBook, or specifically for me, MacBook Pro. Now, for those of you that install Wireshark, it says you don't have permission to capture on local interfaces. So that's what a lot of people may not get, is that there is a computer component for all of this. And for example, network interfaces, not even from a hardware standpoint, not all network interfaces are made the same, if you will. And I remember back in the early 2000s when prior to the current standardization where every laptop had a wireless adapter, you used to have to get a particular wireless adapter that could support promiscuous mode and things like that. We don't really need to do that anymore. But that being said, there is a little bit of a difference installing on MacBook versus other architectures. With MacBook, you actually have to make sure that you install Chmod BPF, which is basically change mode for BPF, whatever BPF is, but change mode is a traditional Unix type, I'm going to say Unix type program to be run. It allows you to change permissions or change what your app can do. Like, for example, you can make your application executable, for example, with change mod. You say change mode U plus X. That gives the user the option of executing a program. That being said, all you have to do if you're on MacBook Pro is just install change mode BPF. You just click on this in blue, and then it would just follow the on-screen instructions. Okay, so that being said, just so you know, this PowerPoint is supplied for you in this course shell, but I'm not even going to go through this, completely. It's just the big thing is you should know now Wireshark is free. As it says, as we are saying, it's used by administrators, security engineers, and the like. Now, how Wireshark actually fits into our cyber investigation, you're using it to capture, filter, inspect, reconstruct, and report. So by reconstruct, what we're saying is that we can roll through a packet capture one step at a time. Okay, so the packet capture itself is divvied up into, it's basically three distinct parts, but there's actually an optional fourth part. So let me just shrink this for a second, and hopefully everyone sees my everyone sees my Cali right here. So please allow me to. And then I'm going to direct you to do this. Go to my taxes 2026. No, I'm just kidding. If you guys want a laugh, just take a look at how much your instructor made in 2025. Haha, no, I'm just kidding. And by the way, I'm down here just so everyone knows, hey, how's it going? Anyways, I spent a little bit of, see how bright, how different it is outside now. Before it was so bright because it was actually a couple hours ago before I made that first video. And between now, if you're wondering, well, what the heck did you do between now and then? I had a huge issue, well, not a huge issue, but I'm having a rather hard time with my other MacBook Pro, my good one. I don't want to say good one because this is an M1, which is still pretty good. But now I'm on this one, but my apologies. It looks a little bit different. I think it didn't get quite as bright out. But that being said, let's go up to my packet PCAP 21. and I'm going to just download it, and I'm downloading it from within my virtual machine. And so we can get to it by type. We can just see downloads, and we do see that PCAP 21 has been downloaded, and let's go to it. And let me just shrink this or compress this, and let me go back to my Wireshark again. And I'm just gonna do Wireshark, and notice I'm gonna put the ampersand um, after the Wireshark to enable my Wireshark to not be tied to my actual terminal. That being said, where I'm going to go to File, and I'm going to go to Open, and I'm going to go to where is where the heck did it go? All capture files. It doesn't even. Oh, downloads. I'm sorry. Hey, this is what happens when we do things live. Anyways, so we're gonna double click on PCAP, and there is our there's our capture right here. Now let's go back to my PowerPoint. First, your packet tracer itself, and let's get. I know you guys love watching me, even though I know you guys don't. But anyways, the the packet tracer itself is divvied up into like three parts. Okay, the three parts are packet list pane, packet details pane, as you can see, and the packet bytes pane. Now we see the packet diagram pane in that yellowish tan color, and the first three are in blue. So obviously, what one doesn't go with the other? And the one that's in tan, packet diagram, is there for a reason, and I'll get to that in just a second. First of all, I hope everyone is enjoying the fact that they don't need to drive all the way to Ypsilanti in order to digest this not wonderful material. I don't want to say wonderful material. So, you guys are probably like, hey, we already know Wireshark. Yeah, I know that, but we're going to do a deep dive. We're doing a deep dive into Wireshark. So by the time you get done with this module, with this week, you'll know a lot more than what you did. But I just wanted to say, I hope everyone is enjoying the fact that they can just learn, and while they're in their PJs, for example. That being said, the first three that are alike are packet list pane, packet details pane, and packet bytes pane. So let's take a look at all of them. Now, look, if you look at just at the PowerPoint, let me get the drawing tool. The packet list pane is right here. Okay, so this would be like in the number one. The packet details pane is right here. So there's a relationship between 1 and 2, and let's take a look at this. The relationship is this very top, they call it the packet list pane. That's what this is. Right now you're seeing 1 through 11, but what you can do, you can take your I'm using my my two fingers, and I'm just gently moving up on my what do you call it, mouse pad, my mouse pad. So as you can go 1 through, and then take a look at this capture, 1 through all the way to 530, we're at over 1600. We can actually scroll down more rapidly to the very end. Almost 4,800 frames are being captured. Okay, so for example, we have frame 470. Okay, frame 470, and the starting point goes all the way up to the top to frame 1. Okay, so we have 1 all the way to frame 4, almost 4,800. So these are the frame numbers. Then we have the time. Now, what time does this actually mean? Okay, what is this? What time? So what it's saying is that, let's say we go from, let's say, frame 8 to frame 9. Okay, what this means is that this frame 8 is the frame at the 0.886771 seconds. And this the next frame was at the 1.012119 second. So if you want the difference between the 8th frame, frame 8, and the ninth frame, frame 9, you would have to subtract 1.0157 from 1.012119. So as we can see, the first frame starts at 0.0000. The next frame is 0.00030. So there was 3/10,000ths of a second difference between the zero and between the first and second frame. Okay, and like I said, it shows this time, source, destination, protocol length, and a one-line summary. Start here to spot odd hosts, bursts, reset, retries, or repeated conversations. Okay, so let's take, for example, the 8th frame. Okay, so the source is this MAC address, and the destination is this MAC address. It is the ARP protocol 42. Okay, 42 bytes. All right, and then the very next part is basically the protocol, the length, and the summary. Okay, so we can move this down, and we can just do this. So the next part is, in fact, information. Okay, and the next part here is we can capture. Oh, by the way, the next part is the packet details pane. So we go from here. Let's click on the eighth frame. Okay, and my apologies. Let me break this down. Let me bring it up here. Okay, let me just go back up. I lost my center right here. So if we go to the 8th frame, all right, when we click on the packet list pane, okay, that influences what we see in the packet details pane. Okay, so if we go to, let's see, DHCP, ARP, DNS, UDP, okay, IGMP. Let me just let me just apply any filter. Let me do TCP. See any TCP right here. If we click on any TCP protocol, for example, okay, we can see that this looks like it's number 92. And frame 92, it takes place at the 7.863650 time. Okay, and let's see. It just is a plain TCP protocol. So whichever entry you click on the packet and what they call the packet list pane, we see the packet details pane has also been affected, because when we click on in the packet list pane, the packet details pane show the details for that single item that you clicked. And also, they show it in reverse. So it relates to you the actual, I'm going to say the TCP IP or the ISO or the OSI model stack. I almost called it the ISO stack. It is the OSI model stack that this is representing, but at least it's representing the slimmer TCP IP or Department of Defense stack. So we're looking at the bottom part, which is the physical. Recall layer 1 was the physical. This refers to the physical aspects of the frame, and these would be, I'm going to say, artifacts of the physical TCP/IP model or the OSI model. You recall, and let me just go here, and you recall that the OSI model was 7 layers, starting with the application layer, and then the presentation, the session, transport, let's see, and then network, and then data link. I'll just say D/L, and then the physical, I'll just say PHY. This is the OSI model, the OSI folks. And then the TCP/IP people came, or the DoD, I'll just say TCP/IP. And what they did was they switched the application, presentation, and session and just called it one big application layer. And then transport was still transport. I'll just say TR. Just say TR. The network layer was kind of changed to internet. And the data link and the physical. Okay. We'll just say these transferred over, but actually they some depending on which literature you're looking at, some models actually did combine these two, and they like to call it network access, but we'll just call this physical anyways. Now, taking a look at this, all right, we can compare that to this. And let me take this right here. And if you could imagine this, if it was flipped upside down. So, physical would be this right here. The data link, let me change the color, would be this. The internet level would be this. Okay? And I'm going to say this is the very top right here. So depending on what frame you're looking at, I'll go blue. And we'll say this transport and app relate to this right here. So as you can see what Wireshark is representing in terms of that bottom link, the bottom part, which is the frame details icon, the frame details pane. So this is the packet list pane. It's divided up into columns, as you can see. We have number, time, source, destination, protocol, link, and info. Okay, but the packet details pane relates to the one and only item on the list that we have I'm going to say highlighted, and it highlights that thing only. And it has like an upside down Department of Defense or TCP/IP look to it. Or that's how it's structured. So the physical or bottom layer is at the top right here, and here is the details that it gives us. We have the layer 2 or data link, the next layer. It's Ethernet 2. And just so you know, that is the standard Ethernet frame. Okay, Ethernet 2 is the newest and latest implementation of 802.3. Okay, and it's just because it is believe it or not, the first implementation was something called DixNet, DIX. The D in DIX stood for digital equipment, or DEC, Digital Equipment Company, and they would become and combine with Hewlett Packard. And wouldn't you know that Hewlett Packard is the company that is identified in this MAC address, because we must have the resolved MAC addresses to hosts here. So it's saying that the NIC card was provided by Hewlett Packard. So it would make sense that the DIX in the original Ethernet implementation comes from Hewlett Packard, which was the D in DixNet, because, as I said, Digital Equipment Company became, or DEX, DEC, eventually became Hewlett Packard. And one of the many local protocols back in the day was DECnet, DEC net. So before there was Ethernet per se, there was DECnet, and DixNet was part of that. So, anyways, DixNet, prior to Ethernet 2, the standard that Ethernet would be best associated with was actually known as DixNet. And the D in DixNet stood for Digital Equipment Company, which would become HP, or Hewlett Packard. Anyways, the I in DixNet was Intel, okay? And the X in DixNet was, believe it or not, it's the copy machine people, okay? Excuse me, Xerox. So believe it or not, the guy who created the Ethernet, Robert Metcalfe, was at Xerox at the time when he created the Ethernet. Anyways, so when Robert Metcalfe originally created the Ethernet, it was called DixNet, and when the IEEE, when they went ahead and they standardized DixNet into an actual IEEE standard, they standarded it as 802.3 or CSMA-CD. Now, we all went through CSMA-CD as an algorithm. Because this is not a networking class, I'm not going to regurgitate that. But the actual symbol is actually Ethernet 2, because Ethernet was originally called DixNet, DIXNet, named after the three companies. That being said, this is why Ethernet 2, that matches mostly with the data link. And like I said, we're going top down here. Next is the internet layer, and that is ICP. Now it says V4, and it shows the host information. We have the source, and then we will have the destination right here. And then finally, we have the very top right here, which is transport and application all rolled into one. Okay, so this is where your application information would be. Anyways, that being said, that is the big deal about how the information is divvied up. So each of them. Now, some of you are wondering, wait a second, what is this right here? Packet diagram pane. Okay, so what you can do here is let me make this did I make it? I must have shrunk this a little bit. Let me change this. Okay. So, once again, your instructor did not make this big enough, make the window big enough. So, let me do some adjustments right here. So, now we have the number, the time, the source, and everything. But anyways, this is the big three format. We have the packet list pane. We have the packet detail pane, which will follow the details of every packet that you see here. And then finally, we have the bits that actually would be yielded from here. So, for example, source port is 49671. That it matches this in hexadecimal. Okay. And this here, let's see, sequence number, that's the hexadecimal equivalent right here of this, of the sequence number, 185. All right? And sequential analysis, okay? All right. Okay, and we can see, for example, TCP payload was 158 bytes. And we can see, if we click on 158 bytes, we can see the entire actual payload right here light up on the right-hand side. Okay? All right, now some people do not think that the packet bytes pane sometimes gives us a lot of useful information. However, we have this packet diagram pane, okay? And really that shouldn't say 3, that shouldn't say 4 in yellow. It should say 3 possibly in yellow, simply because you can't have 4 panes viewable at the same time. You just can't. So what we can do is we can go to our view, okay, and we are looking for, my apologies, we can go to edit, okay, and then we can go to preferences. Now, for those of you that are using Wireshark on a Mac, okay, preferences will be under the Wireshark symbol right here, like all Mac applications. Preferences are under the icon. See for those of you, can you look at the very top of the left side of the window, top left? Look, this is VMware Fusion. See how it says about VMware Fusion and then settings? If you click on settings, that will help allow you to set certain configuration options on it. It's the same thing for Wireshark. So this is just for those of you that are using Wireshark on Kali or some other Linux. Preferences would be under Edit. You're going to go under Preferences, and then we're going to click on Layout. Okay, we're going to click on Layout. And as you can see, there's different panes, okay? And we're going to do pane 3, and we're going to make that third pane the packet diagram. And then we're going to go to Apply. Now, as soon as I click on Apply, you're going to see a live change. See that? We're going to go to OK. Okay, now we can see that every time, we click on a field, we can go to this as our diagram, and we can click on source port, and it will actually reveal, what information in that particular in that respective packet detail. Okay, so source address, we can click on source address and we see it light up. Destination address. Okay, so this is really key for answering particular questions like, what is the destination, Ethernet destination? What is the source Ethernet address? Okay, what if I told you who makes the the maker of the Ethernet card for the destination? And we can see, because we have this configured to resolve Ethernet addresses. What does it resolve to? It resolves itself to the first part of the MAC address. Okay, and okay, so actually, we can adjust that later, but I don't want to make this to this singular video too long. And so again, that's what we do here. So if we want the packet diagram pane to be visible, we have to go back. We have to enable it because some people would feel that the packet diagram gives us more information than the actual bits. Okay, so those are I'm going to say 3. You might say 4, but these are the primary portions of Wireshark, the primary sections. So packet list pane, packet details pane, and packet bytes pane. Okay, and again, this is all things you probably already know. The fact that it says where Wireshark helps us the most. It allows a triage is just a fancy name for basically investigate or make decisions based upon certain findings. So here, what we're trying to do is we're trying to spot retransmissions or suspicious destination IPs and things like that. Investigating malware and phishing callbacks, validating controls and segmentation, and then of course the idea of the fact that we can keep packet captures in perpetuity. That's basically a way to preserve our evidence. Now, examples of a first set of display filters. Okay, so for example, show only TCP traffic, focus only on one host, HTTP, focus only on, for example, logins, and so on and so forth. So let's see. So how you would do this is we could go to our Wireshark. Let me bring up, and I wish you wouldn't do that. And we can say like find, let's see, focus on one host, look for let's see, frame login, check common ports, let's see, we can find large frames, check for common web ports. So let's see, TCP dot port, and we could say in a TCP port in, and this is set notation right here. Okay, TCP dot port in 8043. Okay, let's just do that since it's giving us green. And to make this filter, to apply the filter, we can click the this arrow right here to display the filter. So we can then look at all it only shows us where one of the ports has something to do with port 80. Okay. And right here, so for example, we have destination Ethernet, and let's see, source address and destination address. Okay. So we can see destination address is highlighted and source address is here. So we click on source address, we see that's highlighted. Click on destination address, we can see that is highlighted. Okay. So your first, we are way past this, your first 10-minute Wireshark lab, so we're not even going to worry about this. Okay. So now the next coming videos, we're going to look at Wireshark config profiles, web traffic and default Wireshark display, removing and adding columns, changing time to UTC, adding custom columns, hiding columns, and Wireshark search filter expressions.